Today is a special day because we're going to get to talk about probably the least natural thing that you will ever see in algebra, and that is the idea of a logarithm. And because logarithms are so special and wonderful, I'm going to try to get some help from some other people to help explain what logarithms are and how we can make use of them. So first person that I'm going to ask to help us is a very funny mathematician who is currently the president of Southwestern University in Georgetown, Texas. His name is Dr. Ed Berger. So, Dr. Berger, please take it away.
Okay, now we're going to start thinking about something that gives many students and many adults nightmares. And that is the study of logarithms.
Okay. I'm not sure where you're going with this, but let's hear it.
Now, let me just say a couple words about logarithms before you start to doze off or panic off. A logarithm, as we're going to see, is basically just going to be the thing that's going to untangle the exponential.
Okay, so we're going to untangle the exponential.
For now, what I want us to think about is, what is a log? Okay, well, you know, I struggled with this when I was young. In fact, I sometimes still struggle with it, but I've really got this thing down much better since I remembered one chant. This is a chant that I want you to always remember. If you remember this chant and nothing else in life, well, then you'll be pretty pathetic. If you remember nothing else in life, because you'll forget your birthday and your loved one. But anyway, if you remember this chant just for logarithms, this will get you through a lot of jams. And here is the chant. A log is an exponent. Say it with me. A log is an exponent. If you remember that chant and nothing else, you can get out of almost any log jam that you get into.
A log is an exponent. A log is an exponent. A log. Okay, thank you. Thank you, Dr. Berger, for introducing that topic to us. I appreciate that. All right, now the next person that we're going to go to is going to help us to actually think about how to work with these things. So this is the beautiful Nancy Pie.
You're going to rearrange this and connect it to an exponential version.
Okay, we're connecting the logarithm to the exponential version. Okay?
The base 3 raised to the power of the right side, which is x, equals, set it equals, 9, the middle number or the other number that's left that you haven't used.
Oh, Dr. Berger told us that a log is an exponent. So now I kind of see a connection. So this is the log, and it's the exponent. So in this equation, the exponent is the log. Okay, so if I just put the log up here as the exponent, then that is the exponent. Then if 3 raised to that exponent is 9, then this log must just be 2.
3 to the x power equals 9, which is great because all you have to do is figure out what x makes that true. And since 3 times 3 equals 9, or 3 squared equals 9, then you can tell that x must be 2. And since x equals 2, that's your answer for the log. That log is equal to 2. The log is always equal to a power from the exponential version.
That is incredible. It has taken me years to get my handwriting to be half as good as Nancy's, and she's doing it backwards. All right, and the last person I'm going to consult to help us is that organic chemistry tutor. You may have come across this person if you've taken any chemistry classes. They do math as well, so let's hear it.
Now the first thing you want to do, whatever is on the inside, you want to set it equal to 3 things. You want to set it equal to 0, to 1, and to whatever the base is. In this case, the base is 2. And you want to make a table. When you set it equal to 0 and you solve for x, this is going to be the equation of the vertical asymptote. When you set it equal to 1 and 2, whatever values of x that you get are going to be the points that you want to plug in. So let's find y when x is 1. Log 1 is always equal to 0, regardless of the base, because anything raised to the 0 power is 1. Now if we plug in 2, log base 2 of 2, these are the same, they cancel, it's just 1. 2 to the first power is 1.
Okay, so there was a little mistake there. He said 2 to the first power is 1, but we all know 2 to the first power is 2. That's okay, we all make mistakes. The method that he's telling us is a great method for graphing these logarithmic functions, these logarithmic equations. They said the part in parentheses, set that equal to 0, set it equal to 1, and set it equal to whatever the base is. So for us, what's in parentheses is just x. So we get these. And whenever you set it equal to 0, that's where the vertical asymptote will happen. There's a good reason for why that's the vertical asymptote. I won't talk about it right now. All right, let's keep listening.
The vertical asymptote is x equals 0, which is basically the y-axis. Now we have the point 1, 0, which is an x-intercept, and 2, 1. So to graph it, start from the vertical asymptote and follow the 2 points. And that's a simple way to graph logarithmic functions.
That was so easy. Thank you, that organic chemistry tutor. That was very helpful. Super useful method for graphing these logarithmic functions. So I appreciate that. You watching this may still have the question, why do you get a vertical asymptote when the stuff in the parentheses is equal to 0? So at the x value that makes the stuff in parentheses equal to 0, why do you get that vertical asymptote? Well, you tell me.